Hi. So for Robotics Laboratory, this is laboratory activity number 3. It is entitled Control of Servo Motor. So for this experiment, the objectives are the following. This experiment will enable the student to control the angular displacement of the servo motor. This second objective here is about the computer program user interface. We are going to disregard this since we're not asked by our instructor of our professor to not do this. Next, the equipment and materials used in this experiment. A personal computer, one Arduino microcontroller, one servo motor, one power supply. For the power supply, I would be using this cord. This end of the cord here is to be connected to the power port of the Arduino Uno, and this one is for the personal computer USB port. One set of connecting wires. For a brief introduction about this experiment, so in this activity, we will control the movement of the robotic arm, which joints are composed of servo motors. The movement of the conveyor is controlled through a program implemented in Visual Studio and Arduino. The Arduino microcontroller will control the servo motor, and the Visual Studio will provide the interface to execute commands. So this, in terms of the Visual Studio, we will not be using this application since, again, we were not asked to create a program user interface to control the Arduino. On the other hand, what we'll be using is the serial monitor in our Arduino IDE application. So moving on, the servo motors are connected to the microcontroller. The microcontroller will send pulses to the servo motor with different width that corresponds to the angle's rotational displacement of the servo motor. Angular data is needed to be fed to the microcontroller to instruct it to rotate in that angle. So this last paragraph here is all about the graphical user interface, so let's just skip that. So for the procedures, the setup, of course, we need to connect our Arduino to our computer using the USB cable, and the other end is connected to the power supply of our Arduino. Next, this is the connection that we need to follow for our experiment. We need to connect the black cable to the ground, the black cable of the servo motor, the red cable to the 5V of our Arduino, and the yellow pin to the pin 9 of the microcontroller. So now let's open our FreeSync application and connect our circuit like this. So there, let's get us some breadboard, just a small one, and a servo motor, of course our Arduino Uno Rev 3, and let's connect the circuit like this. So this is our completed circuit connection. So for our schematic, FreeSync also offers a schematic view of our created circuit. So here, let me just fix this a little bit. This is our schematic diagram. So now, here are the equipments and materials that we need. So let's start and build the circuit. So this is our completed circuit construction. So now let's create our code in our Arduino IDE. Moving on to our experiment. So for our Arduino program, we're asked to create a program for the microcontroller that will control the angular displacement of the motor by sending pulse with different width that corresponds to the angle of the servo motor. So for the first part, or the first code in our experiment, so I've included the servo library. I've also included this integer angle of 0, and the servo is named my servo. So the void setup, the code will begin at 9600 baud. The servo is then attached to an output of pin 9 in the Arduino microcontroller, and the loop goes like this. So when angle is equal to the serial parse integer, or the value that we've inputted in our serial monitor, then the angle is if the angle is greater than 0, then the servo will write an angle in our servo motor according to what is the serial number, what is the angle printed in our serial monitor. So also this serial dot println angle displays the value of the angle that we will type on our serial monitor, and the rotation of the motor will have a delay of 15 seconds. So let's click on upload and try the code if it works. Now that we have our circuit and code, let's try to simulate. So let's open the serial monitor to check if the servo rotates according to what value I'm to input in our serial monitor. So let me input 10. There, it moves. Another one, let input 20. There, 30, 40, 50. Now let's try 100, 150, 180. So as you can observe, it's 180 degree. Earlier the point was here and now it's there with a 180 degree. So let's try 10 again. There, as you can see, and 180, 10. The second part of the experiment, the servo rotation using for loop. So for this part of the experiment, this is the code. We've included the servo library. So also, we've renamed the servo as servo underscore test to initialize a servo object for the connected servo. Then we have also declared an integer value that angle is equal to 0 always. Next, the void setup. servo underscore test dot attach 9. This means that our output for the servo is attached to pin 9 of the GPIO in our Arduino. So for the loop, we have four loops. So for the loop, we have two for codes. So for the first condition, when angle is 0 to 180, this means that the angle will have, or the servo motor will have an increment of +1, and the delay of this loop is at 15 seconds. So this servo underscore test dot right angle is the command to rotate the servo to the specified angle. So for an angle of 0 to 180, the loop will continuously have an increment of 1 and a delay of 15 milliseconds. And when it reaches 180, there is a delay of 1 second or 1000 milliseconds. And then the next loop will apply. So when the value reaches 180, the angle will then be greater than 1 and the angle increment is less than 5. So this will make the servo move faster than an increment of 1. So the next part of the code is servo underscore test dot right. So again, this command is to rotate the servo to the specified angle. So from angles 180 to 0, the delay will be 5 milliseconds, which is faster than the delay of 15 milliseconds. So from this code, we can expect to see that when the servo reads an angle of 0 to 180, it moves slowly. But when it reaches an angle of 180, the servo will rotate or move faster compared to the first for loop. So this loop, after this loop for the for 180 to 0, it will also have a delay of 1 second, and then it would repeat again for when the angle would be 0 to 180 and then 180 to 0, and so on and so forth. So now let's try to upload this to our Arduino. Let's click on upload, compiling sketch, uploading. The Arduino is blinking, and as you can see, our servo motor rotates. So that's what I'm saying, from 0 to 180. It's a slow increment. There. And when it reaches 180 degrees, the delay of the loop becomes faster. As you can observe from a faster movement of the servo motor back to 0 degrees. The delay of the loop is slower, faster. There.